In this chapter, we will be analyzing rational expressions and equations. In this lesson, we will be adding and subtracting more complicated rational expressions.
All right, hi everybody. In this lesson, we are really going to just go over ground that we've gone over before. We're just going to do it with slightly more complex fractions. Basically so that you get a sense of how difficult these are likely to get on any kind of an assessment here. So let's just take a look at the rules again. So if you've got rational expressions, if they have the same denominator, all we're going to do is add or subtract the numerators. Straightforward as that. Now, what you're going to do is you're going to combine the numerators together, and then you're going to look at it and see if you can factor and cancel. Okay, so that's always going to be your end kind of game there. You're going to look at that. Once you've put it together, factor and cancel if you can. Now, if you've got different denominators, then you're going to need a common denominator. Okay, so you're going to need the least common multiple for the denominators there. So you're always going to factor the denominators, and then you're going to check to see if you can further simplify here. And bear in mind, we need to identify non-permissible values. Okay. That should be something that we do all the time now. That's why it's not even mentioned there. It should be just something you do automatically. Anyway, this lesson here is really just about more practice with doing the procedure that you're already fairly familiar with. All right, so here we go. So to start off with, what we're going to do here is we need to factor. Okay. Well, in this first expression here, there's really nothing to factor. Those are as simple as they're going to get. But in this second expression here, notice that the denominator here could be factored. So x and x, that's how I'm going to get x squared. And then I'm looking for factors of -3 that are going to combine to -2. Now, I'm guessing that x minus 3 is a common factor. And then this would be x plus 1. Now, let's just multiply that out. +1, -3. Yeah, there's my -2. Good. So there I factored it here. Now, my common denominator has got to have that x minus 3 in it, but it's also got to have the x plus 1 in it. Okay? So x minus 3, x plus 1. Now, what that means here is this factor right here, okay, or sorry, not factor, that's a mistake. This addend, this first term here, is missing the x plus 1 factor in the denominator, so I've got to put it there. And if you put it in the denominator, you've also got to put it in the numerator. Now, my second term didn't have a problem. There was nothing missing. So I don't have to do anything to the numerator. The denominator was complete. Now, I am going to put these all over that denominator, x minus 3, x plus 1. That's the whole point. The denominators are the same here. So really, whatever the numerators are, when I total them together, it's going to be over that same denominator. But now I have to expand this out. So this term is going to be 4x squared. That's going to be positive 4x minus 5x. So minus x minus 5. And then over here I've got a minus 4x squared. Okay, good. So I've expanded the two pieces there, put them together. Now I'm going to just perform that addition or subtraction. Now in this case it's a subtraction. So the two like terms here are the x squared, so the 4x squared minus 4x squared, they're going to cancel. And I'm left with negative x minus 5 over x minus 3, x plus 1. Okay, now I could factor the numerator by taking out a common negative sign, but that's really not going to do anything for me because I can see right now that x plus 5 that I would get with isn't going to cancel with anything. So this really is about as simple as that's going to get. Okay? That's really as far as I need to go. Don't expand the denominator because if you do, you're going to lose the obvious non-permissibles and the obvious factors there if they ever cancel here. Now, even though in this case I didn't cancel any of the denominators, so I don't absolutely need to mention this. If you want to make sure that you get those marks there, we really want to state the non-permissible. So x cannot equal positive 3 and x cannot equal -1. Okay, let's move on. Next. Once again, the very first thing I'm going to do is factor. Okay, so I look at the numerator here. That's as simple as that's going to get. But the denominator is a difference of squares. So x minus 3, x plus 3, plus, okay, my numerator here is pretty simple, 4x. There's nothing much I can do here. but the denominator is a trinomial, so I can split that up. That'll be x and x. And now I'm looking for factors of negative 24 that combine to get negative 5. Okay, well that's, I think about it a little bit here. That should be pretty quick that it's going to be negative 8, positive 3. And I'll just double check that. Negative 8, positive 3 gives me negative 24. Good. Add those together, I get negative 5. Good. Okay. So my common denominator, when I get it, has got to have an x minus 3 in it. It's got to have an x plus 3 in it. Now that one was common already, but that was good. And then this one's got to have, it's also got to have an x minus 8 in it. So plus, and then my denominator here is going to be x minus 3, x plus 3, x minus 8. Good. Now, to go from this denominator to this denominator, I've got the x minus 3, I've got the x plus 3. What I'm missing is the x minus 8. So I need to plug that into the numerator as well by multiplication. Over here, my denominator's got the x minus 8, I've got the x plus 3, so I'm missing the x minus 3 factor. So I've got to include that. All right, now my denominators are identical, so I can put this whole thing over the same denominator, and I'll make sure we can see all the pieces here. So this will be over x minus 3, x plus 3, x minus 8. And now I'm just going to expand. So 2x times x will be 2x squared, minus 16x, minus 5x, so minus 21x. The negative 5 times negative 8 will be positive 40. Over here, when I distribute that through, it'll get positive 4x squared minus 12x. Okay, oops. Now that's me putting the pieces together, multiplying out those pieces. I added, okay, and that's why these two terms stayed the same sign, because the addition isn't going to change anything there. And so now I'm going to group together the like terms that I see in the numerator. So I've got 2x squareds here, 4x squares here. That's a total of 6x squares. I've got a negative 21x and negative 12x. It's going to be minus 33x. And then a plus 40. Oops, make that sure that looks like a 40 there. Ah, that just got worse. Plus 40. All right, now what I would do, now that I've put it all together, now I would look for common factors there, or any kind of factoring that I can do. In terms of common factors, there are none. Okay, because 6 is the one I'm really going to use to lead me through that. 6 can only be broken down into 2 and 3. 2 is not a factor of 33, but 3 is not a factor of 40. Okay, so there is no common factor there. Now, maybe I can factor that, but I'm going to use my discriminant to figure that out. So let's take a look at that. So that would be negative 33 minus 4 times A times C. So let's take a look at that. If I plug in negative 33 squared minus 4 times A times C. Now, did I get that right? Yeah, the signs are all correct there. Good. If I press enter, I get 129. Now, if 129 is a perfect square, then this is factorable. It is not factorable. So that's where I stop. Now, hopefully you can recognize quicker than that whether or not that's factorable or not. But if you can't, that discriminant is always a really good little tool here. So this is not a perfect square. If it was a perfect square, then you could have factored that. Now, even though nothing canceled, I should still list the non-permissible, so x cannot equal 3, can't equal negative 3, can't equal positive 8. There's my answer. Let's take a look at another one. Okay. Now here, again, my first step is going to be to factor. So I'm going to get 2x over, all right, well that's going to be 2x minus 3, 2x plus 3, because that is a difference of squares. Minus x minus 3 over, okay, now I've got this trinomial there. I see a 4x squared and a 9. Now, I would be very tempted to make this, 2x and 2x. Now, I'm just guessing. It could be 4 and 1 for all I know, but the factors of 4, the most common ones that get used are 2 and 2. And then with the 9 here, I'm guessing it's going to be 3 and 3, just because they're perfect squares. Now, this is positive and this is negative, so that positive tells me that those two have to have the same sign. and they're going to be the same sign as what I'm seeing in that middle term, so it's going to be negative and negative. Now, does that work? Negative 6, negative 6? Yes, it does. Good. So my common denominator has got to have 2x minus 3 squared. Notice this denominator has it twice. This one only had it once. But I need it to show up. I need to be able to see in my common denominator every other denominator. So if I'm going to see this denominator down here, I need to see that one, that 2x minus 3 twice. And then I need to have that 2x plus 3 so that I can kind of see that denominator in this one. Minus, and then this would become 2x minus 3 squared, 2x plus 3. So now I'm going to go to my numerator. What did I have to do there? Well, in this term, when I compare this denominator to what is the common denominator, I had to multiply this by an additional factor of 2x minus 3, which means I have to multiply the numerator by an additional factor of 2x minus 3. In this denominator, sorry, this one right here, what factor was missing? Well, it was the 2x plus 3. So that means I have to put an additional factor of 2x plus 3 into the numerator. Now, here, notice my denominators are both the same, which means I can assume that that is going to cover the entire denominator. And now what I got to do is I just got to expand out the numerator so that I can then simplify it. So here, 2x distributes through. I'll get 4x squared minus 6x. Okay, now here, there is a negative here. This subtraction is going to change the signs as I work through here. So this is going to become x times 2x squared. So it's going to be 2x squared minus 2x squared. 3x minus 6x is going to be negative 3x. That negative changes it to positive 3x. Negative 3 times positive 3 is negative 9. That negative changes it to positive 9. Okay, now I come over here, keep writing this. So this will be 2x minus 3 squared, 2x plus 3. And then putting the two pieces together, or sorry, all of the pieces together here, 4x squared minus 2x squared will be 2x squared. Negative 6x plus 3x will be negative 3x plus 9. Now, I put it all together. Can I factor that? Now, this is where my focus is. Now, let's check that discriminant again. So, negative 3 squared minus 4 times a times c. So negative 3 squared will be 9, minus 4 times 2 is 8, times 9 is 72. Okay, you know what? I don't even have to finish doing this to know that this is going to equal a negative. And I'm not going to be able to take the square root of that and get a real number. So that's the dead end. It's not a perfect square. It's not going to work out the way I want it to. That's the last step there. So now all I got to do is state the non-permissibles. So x cannot equal... well, remember, if I set this equal to 0, that's going to be 3 divided by 2. Here, this would be negative 3 divided by 2. So those are my two non-permissibles, 3 over 2 and negative 3 over 2. Let's keep going. Okay, whoops, number 4 up here. Okay, well, this one's gotten a little bit more busy. Okay, I've got 3 terms now. But that doesn't change anything. All this does is make it so that the work that I do, it just takes me a little bit longer. That's it. Okay, I'm still going to do the same thing. I'm still going to factor. Okay, now I've got the trinomial in this first term, so that'll be x and x to get x squared. And then I need factors of 16 that add to negative 10. That's going to be negative 8, negative 2. Okay, wow, this one right here. I don't like the way that looks. Man, I really don't. I'm going to switch the order of those, make that negative x plus 2. And then I really don't like the fact that there's a negative out front, so I'm going to factor that negative out. So that middle term there, that negative can pop out, change that addition to a subtraction, and I'm going to get 2x over x minus 2. I love that much more than I like that question. That just wasn't pretty to me, so I'm going to make it so it is pretty. This isn't pretty either. I don't like this either. So I'm going to, again, make this negative x plus 4. I'm just going to change the order. And then I'm going to factor that negative out, make that x minus 4, and then that negative there will cancel with this one that's right there. So this will become positive x minus 4 over, and then down here there is a common factor of 3, which will make that x minus 8. Okay, so there's a lot going on there, but I haven't even gotten all that far. All I've done is my factoring. Now, I need to come up with a common denominator. Well, my common denominator's got to have an x minus 8 in it, because this term does, it's got to have a common x minus 8 in it. It's also got to have an x minus 2 in it. I see that there and there. And interestingly enough, it also needs to have a 3 in it, because that 3 that shows up right there. Okay, so there we go. So it'll be this term minus this term, but it's going to have the same denominator. And then this one right here, going to have the exact same denominator. So it'll be x minus 8, x minus 2, 3. So going back to this first term, what factor is missing in the denominator? It's just the 3. So I'm going to multiply the numerator there by that 3. Okay, and if you cancel those 3's out, you go right back to the original. Here, this one's missing a couple. It's missing the 3. It's also missing the x minus 8. And the numerator was 2x. Here, this one was simply missing the x minus 2 factor. So it becomes x minus 4 multiplied by x minus 2. Okay. Now, by looking at this, you should be able to simplify this to the previous step by just canceling out common factors. You should be able to do that. And if you can do that, then you've done it correctly. Now, though, I know that my denominator is going to be x minus 8, x minus 2, and actually it looks better to put the 3 up front. So I'm just going to do it like that. Now I'm going to expand the numerators. So this will become 3 times 5x minus 2 will be 15x minus 6. That subtraction in front of this term is going to change all the signs here. Now let's just think about this. This is going to be 3 times x times 2x. So that would be positive 6x squared, and that negative is going to make it negative 6x squared. This would be 3 times negative 8 is going to be negative 24, times 2 would be negative 48x, and that negative is going to make it positive, so positive 48x. Then I still got another term here. This will become x squared. Now notice the addition sign here means that all of the signs that I get here will stay the same. This will be negative 2x, negative 4x, so minus 6x. And then negative 4 times negative 2 will be positive 8. Okay, so 3x minus 8, x minus 2. Let's put together the like terms. I've got a negative 6x squared and a positive x squared, so it'll be negative 5x squared, okay. I have got a 15x, a 48x, so putting that together, that is going to be, what is that, 63x. Minus 6x will be minus 57x. And then I've got a negative 6 and a positive 8, so it'll be positive 2. Now I'm just going to double check that. 63 minus 7, yeah, 57. Okay, now I need to simplify that. Now I could factor out the negative there. I don't know if that's going to make much of a difference. Let's see if this can be factored. Okay, let's see if that can be factored. So let's check the discriminant. That's going to be negative 57 squared minus 4 times a times c. Now let's just take a quick look there. Okay, so you see that? So negative 57 squared minus 4 times, what was it again here? Negative 5 times 2. Can I take the square root of that answer? Nope. Nope, I don't get a nice number there. So that tells me that that is as nice as that's going to get. Now I could take out that common negative, or that negative that's out front here, but that's really not going to make much of a difference here. So I'm simply going to state that x cannot equal positive 8 or positive 2. Okay, there we go. Let's take a look at the next one. Once again, we got a bunch of factoring to do. So this will become 5 over This has got to have an m and an m, and I'm looking for factors of positive 15 that add to negative 8. Well, it's got to be negative 3, negative 5, minus 3 over, in this case right here, it'll be m and m once again, and then factors of 12, positive 12 that add to negative 7 will be negative 3, negative 4, plus 2, and then once again, same sort of factoring here, m, and then factors of positive 20 that add to negative 9 will be negative 5, negative 4. Now, I mean, when you take a look at that, it should be fairly clear that my common denominator is going to be m minus 3, m minus 4, m minus 5. m minus 3, m minus 4, whoops, m minus 5. m minus 3, m minus 4, m minus 5. All right, so in this first term, what factor was missing? Well, it was the m minus 4. So I've got to put an m minus 4 in the numerator as well. If you simplify this term by canceling what's common, you go right back to the previous step. Here, the factor that was missing was m minus 5. Again, if you cancel those terms, you go right back to the previous step. And here, the term that was missing was the m plus 3, or sorry, m minus 3. Wow, m minus 3. And again, if you cancel those, you go right back up. So here we go. All of those are over the same denominator, so m minus 3, m minus 4, m minus 5. Now I'm just going to expand the numerator, and this is actually quite easy. These are just, they're not even going to end up being quadratic, which is great. This is going to be 5m minus 20. That negative is going to switch the signs that I get here, so I'm going to get 3m, or negative 3m, minus 15, plus 15. The addition here means that all the signs that I get are going to stay the same, so this will become positive 2m minus 6. Okay, now my denominator stays the same, m minus 3, m minus 4, m minus 5, and I'm just going to simplify. So 5m minus 3m is 2m, plus 2m is 4m. 20, or negative 20 I should say, plus 15 is negative 5, minus 6 is negative 11. Now, normally what I would be looking for at this point here is the ability to factor the numerator to see if there's anything I can cancel, but that 11 is really killing that idea. Okay, I'm not going to be able to factor out that 4, so this is kind of the end. So I'm simply going to state my non-permissibles. M cannot equal 3, 4, or 5. All right, now finally, in this lesson, another question here. We're just going to, again, we just got a factor here. So we got this trinomial, so x, and we're looking at factors of positive 18 that add to negative 9. It'll be negative 3, negative 6. Factors of 24, positive 24 that add to negative 10 will be negative 4, negative 6. Okay, so my common denominator has got to have the factor x minus 3 in it. It's got to have x minus 6 in it. That's shared by both of those. But it's also got to have that factor x minus 4 that was left over here. So that's my common denominator. It's going to show up in both. Actually, sorry, I should write this exactly the same as I wrote the previous one. X minus 3, x minus 6, x plus 4, or minus 4. Now over here in this first term, the term that was missing was the x minus 4. So I'm going to include it in the numerator. Over here, the factor that was missing was this x minus 3, so I'm going to put that in the numerator. Now, both of those are over the same denominator, so I can simply write those as being over the same denominator. Now, multiply that through, I'm going to get x squared minus 4x. Because of the addition in between, when I get my signs here, they're all going to stay the same. So this will be x squared minus 3x minus 2x, so minus 5x plus 6. Okay, so my denominator still stays the same. Now, x squared plus x squared will be 2x squared. Negative 4x minus 5x will be negative 9x plus 6. Okay, now once again, I am going to check my discriminant. Can I go any further than this? Okay, so let's check here, negative 9 squared. That's my b squared, minus 4 times a times c. Now 33, whoops, my answer here is 33. 33 is not a perfect square. 36 is, but 33 isn't. So that means that is as good as that's going to get. So all that's left for me to do here is to identify the non-permissibles. X can't equal 3, 6, or 4. And that's it. We're done.